Now, how to use datasheets and registers. Here are a few Atmega 328P registers. The registers control the functions active in the chip and the information returned by the peripherals. With the data direction register, you can control if the 8 pins controlled by the register are going to be inputs or outputs individually. This is much like the pin mode function in Arduino, where each bit in the register represents a specific pin, and a 1 or 0 decides whether it is an input or an output. The port register is the next register to discuss. It is the low-level equivalent to digital write. If a bit is set to 1 in this register, the corresponding pin goes high. These two registers form the most basic function and are a good way to start speeding up your code. The last register on this page is the pin function, and it is analogous to the digital read function. If a pin is high, the corresponding bit will be 1. It is a read register, but you can write in it, in which case the corresponding bit in the port register gets written too. The code to use these registers looks a little bit like this. Here you can see the use of the bitwise operators. In this example, we set the data direction register B so that a 1 is shifted to the bit 0 and a 1 is shifted to bit 3, setting pins B0 and B3 as output. To know which pins you are using, some of the pinout diagrams include names of the Atmega 328P pins. Names of the Arduino pins do not equal Atmega 328P pins. The datasheet is like an Arduino reference page, but for the chip. It is a manual, and the one supplied with the Atmega 328P is a very nice one with code examples and clear explanations. If you ever want to know something about the chip, consult the datasheet. The datasheet is the new reference page where everything is explained, and it is your best tool. The time can be used to measure time signals of the chip, produce signals, and create timed interrupts. It features a counter register which takes clock pulses either from an internal oscillator or from an external source. The characteristics of this timer, like if it counts up or down, can be programmed. It is as an output compare register which you can set a value to, and if the counter register value equals to that compare register value, it sets a flag in another register, and if programmed to do so, it can fire an interrupt. Then once the interrupt has been fired, it can be programmed to reset or keep counting until the reload. There are 3 interrupt moments that can be set. The first one is the overflow bit, and sets when the counter register is full and has to be reset to 0 and to keep counting. The second and third compare match events when the compare register matches the counter. All the details of this are in the datasheet. And an interrupt can be written like a function, where you just have an interrupt service routine, where you can just place your code so that whenever an interrupt fires, you can have a custom piece of code run.